Hey guys, today we're going to talk about how to factor something called a difference of squares. Now, we've actually factored what we've called a difference of squares before, but we call it no middle term. Now, you can still use no middle term, even if it's not a difference of squares, but this is like a shortcut if you can recognize that you're factoring the difference of two perfect squares. So like I said before, how we have factored difference of squares is we've said, oh, there's no x's here, so we turn this into x squared plus no x's minus 9. Then we made our t-chart, -9 on top, and that was going to be -3 and +3, and they add to 0. So then we would have our x squared minus 3x plus 3x minus 9, factor by grouping, factor out a greatest common factor of x and 3, and we would be left with x times x minus 3 plus 3 times x minus 3. So you can notice that our final answer would be x minus 3 times x plus 3. So it's going to have the same terms, so x and 3, but one's plus and one's minus. If you can remember when we were multiplying polynomials together, we called this, it was like a shortcut, and we called it the sum and difference. And we knew that we would just have to square the first term, square the second term, and then put a subtraction sign in between. So now we're going to use the shortcut kind of backwards. So what I mean by this is the shortcut is if you notice that you can take the square root of the first term and the last term. So for example, my first term is x squared, the square root of x squared is x, and then my last term is 9, the square root of 9 is 3, I can just say that this is going to be x plus 3 and then x minus 3. So we're going to have our two binomial factors, but one's plus and one's minus. And again, this first square root of the first term goes in the first spot, and then the square root of the second term goes in the second spot. Okay, let's do a couple more of examples. So again, if you see that you have two terms, okay, and they are taking the difference of them, see if you can take the square root of each term. So my first term is 49x squared. I'm going to take the square root of 49x squared, and that's going to give me 7x. And then I want to take the square root of 16. That's going to give me 4. So my final answer here is going to be 7x minus 4, and then 7x plus 4. Again, you don't have to do the t-chart thing. You can just say that it's a difference of perfect squares shortcut. Okay, now it might not just be simply a difference of two squares. Right now I have in example 2, -2c cubed plus 8c. So I see that I have a greatest common factor I can factor out first. So this would just be, hey, a normal factoring problem. But when I go ahead and factor out my greatest common factor of -2c and pull that out in front, I now have left c squared minus 4. Well, c squared minus 4 is a difference of squares, so this isn't fully factored yet. I need to factor one more time using my difference of squares. So c squared minus 4 can be factored further. So this is actually going to end up being -2c times c minus 2 times c plus 2. Now, where did I get the c minus 2c plus 2? I can take the square root of c squared, which is c, and the square root of 4, which is 2. So I can go ahead and put c in the first spot, 2 in the second spot. So difference of squares is going to be something that you're going to have to recognize, because if it is in one of your two binomials at the end, you're going to have to factor by difference of squares to fully factor. So I do have this small flow chart here for you to kind of go through all the steps to make sure you've completely factored every time. So again, you always want to start to see if you have a greatest common factor first. If yes, factor that out. If no, or if yes, then determine how many terms. If it's 4 terms, you're going to factor by grouping. If it's 2, do I have a difference of squares? If yes, factor that. If no, then you're done. And if it's 3 terms, you still want to do your t-chart factoring. But then again, always double, triple check. Do I have a greatest common factor, or do I have a difference of squares left in one of my two binomials?